Hey guys, Mr. Bowman here. Today's learning objective is in green. Up the top, we are learning to use our parabola skills to solve problems from given contexts, including finding optimal solutions. So this video is going to focus on the idea of finding optimal solutions. And the context that I want to consider this is something that happens in farming and agriculture quite a bit, but I've made a more example related to me. So I am genuinely interested in starting a vegetable garden, and I've just made up. Perhaps I've gone to Bunnings or Mitre 10 and have bought 100 meters of fencing. With that fence, I want a rectangular vegetable garden, and we're trying to find, well, what's the maximum possible area that I can have for my veggie garden with that fencing. So what we're going to do is we're just going to start off. So if you think of our vegetable garden, they're always rectangular. And we'll have two sides. We're going to call them X. And the other sides we're going to call Y. And what we know about the garden is the perimeter of the shape. Well, that has to be the 100 meters of fence that we have available to us. And that's going to be equal to 2 times X plus 2 times Y. So that is an example of an equation, but what we can do is we can also use our table and our graphing skills to find out the maximum possible area. So let's switch back to a different color pen. So let's use the yellow pen. Let's get into a table. So the first way I want us to do this is let's investigate the relationship via a table. And to do that, we're probably going to need quite a big table comparing X and Y and the resulting area of those. So I've done my table vertically. You can do it horizontally as well. So let's run. So if X is 0 meters, the two side lengths of Y, well, they're going to be 50 meters. And the area of that, well, that would be 0 meters. So maybe we go in 5 meter intervals. It didn't quite do my table long enough. And I'm stopping at 50 because it does appear that 50 is the highest X value that we can get. So if X is 5, that means there's 100, that means there's 90 meters left for the Y's, and they would be 45. And if you put that in your calculator, 5 times 45, well, that'll get you the area of 225. So let's have a look at 10 now. 10 plus 10 is 20, so there's 80 left for the Y's, which means that's going to be 40. And 10 times 40, well, that's 400. So straight away, we've already got a bigger amount or bigger area. So 15, so that's 30 for the X's, which means there's 70 left, which is 35 for the Y's. 15 times 35, 525. So again, bigger area. So we've got 20 for X. 2 of those is 40. That means we've got 60 meters left for the Y sides. So that means that's going to be 30. 20 times 30, well, that's 600. So again, we're still increasing. We've got 25 for the Y's. Also 25 for the X's. That means 25. And notice there is a pattern with the Y's. The Y's are consistently dropping by 5. So let's carry on with that pattern. And we got 25 times 25. That's 625. So we're still increasing our lengths. And then we got 20 times 30 again. So that's 600. We've already calculated that. And just remembering, parabolas are symmetrical, so we will see an element of symmetry. 15 and 35, well, that gives us 525. 400, 225. So again, symmetrical. And finally, 0. So what we've done is we've used a table, we've mapped out all the different combinations within 5 meter intervals, And what we've done there is we found out, well, the way for me to maximize the area of my veggie garden is the X length, well, that needs to be 25 meters. So if we have a look at our shape, so that there needs to be 25, and the Y length also needs to be 25. And that results in an area of 625 meters squared. And that there is what we call the optimal solution. And it's the maximum area given the limited amount of fencing we have available for our veggie garden. So it's a pretty huge vegetable garden. That's probably well beyond my ability to maintain. So that was the first method. We looked at the table. Now what I want us to do is I'm going to pause the video. Make sure you get that down. We're going to switch to another method. You may prefer the other method. We're going to focus more of an equation-y graph type method to find the optimal solution. Hey guys, we're back. And what we're going to do here is we're now going to focus on the equation / graph side of parabolas. So both methods will be perfectly acceptable. You'll definitely get your marks in a test, but let's have a look how we can do this. So just a reminder, when we're trying to graph something, you do need an equation that's y equals something. So we need to algebraically change our equation. So what I'm going to do is I'm going to write our equation up here. So 100 is equal to 2x plus 2y. So what I'm looking to do is I'm trying to figure out what y is equal to. So let's mathematically rearrange for that. So that's going to be 100 minus 2x, because I'm going to take the positive 2x and move it to the other side. And that's going to be equal to 2y. I'm then going to take this times 2 over to the other side as divide by 2. So that's going to be 100 minus 2x divided by 2. That's going to be equal to y. And that means y is going to be equal to 100 divided by 2 is 50. And 2x divided by 2 is x. So y is going to be 50 minus x. Which when you think about it, it makes sense, because half the perimeter will be the blue area, which will be 50 meters. And y will be, well, 50 meters less whatever you used for x. So that makes sense. And if we put that into an equation, if you think of the area, so the area is going to be equal to base times height. The base of our shape, if that is x, the height of our shape is going to be 50 minus x. And all of a sudden, that's the formula for a quadratic or a parabola. And we can actually go away and draw and graph that parabola. So let's draw or sketch up just a quick graph. So what I'm going to do is I'm just going to draw the x and y axes, mainly in the positive area, because you can't have a negative length or a negative area. And what this equation tells us is some good information about the x-intercepts. So let's find out what they are, because that is how we can find the vertex. So at the x-intercepts, we know that y is going to be equal to 0. So 0 is going to be equal to x, 50 minus x. That means x1 is going to be 0 for that one there, and that there, x will be equal to 50. So those are our two x-intercepts. So let's put 1 point there, 1 point there, and that point is 50, 0, and that point there is 0, 0. And we know the vertex is going to be exactly between those 2 points. So the vertex would be x1 plus x2 divided by 2. That's going to be 0 plus 50 divided by 2, and that's going to be equal to 25. So we know our vertex, that's going to be somewhere along that 25 line. And the final step, what we can do is if we put the x back into the equation, we'll be able to find out the corresponding y value. So we'll do that. So I'll just put a line between steps so we know what we're doing. So those are our steps. And let's do our final one. So y is going to be equal to 25 times 50 minus 25. That's 25 times 25. And that there is 625. And that would be the y value of our vertex. So I'm just going to draw a dot up here. So that means that y value is 625, meaning the coordinate 25, 625. And if we drew our parabola from that, it would look, it's a terrible parabola. It would look a bit like this. And we found the coordinates of the turning point or the vertex. And in our case, the vertex is a maximum, and that makes sense because we're trying to find the maximum possible area. So in our case, if we draw like we did before, we've got our vegetable garden, 25 meters by 25 meters will give us an area of 625 meters squared. And we know that because the x-intercept, or the x for the coordinate of the vertex, is 25 meters. Those are the two x values. So that and that would be 25, leaving 50 meters for the other two sides. So they have to be 25 as well. So this method is very algebraically, and some of us may prefer the table method, some of us may prefer the equation method. Whatever your preferred choice is, use that. Okay, hopefully you found the video useful. Make sure you get the examples with the working down. Now let's get into heaps of questions.